This video will show examples with the binomial theorem. Expand a plus b to the power of 4. So the way I like to do these is I begin by writing blanks for the coefficients, and I just write out the variables to their correct powers first. So the first one is a to the 4th. Then we have a cubed b, coefficient a squared b squared, coefficient ab cubed, and coefficient b to the 4th. Now, in order to find the coefficients, there are two ways we can do that. We can either use Pascal's triangle, so we could write out 1, 1, 1, 1, 2, 1, and write out all of the rows until we get to the row corresponding to the power. So now we see this and we can stop. And these correspond to the coefficients. Or we can use combinations and say that our coefficients are equal to 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And since we know that these are symmetrical, we can take a shortcut and only find the first 3 and then use the rest by symmetry. So 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 2 is 6, and since you know it has to be symmetrical, we can fill in the rest. Either way, we get the same coefficients for our expansion, so we can say that it's equal to a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Expand 2x minus 3 to the power of 5. So we'll use the same strategy that we did in the last example. So we have coefficient 2x to the 5th plus coefficient 2x to the 4th and our last term, coefficient negative 3 to the power of 5. Okay, and now I'm just going to choose using Pascal's triangle to find the coefficients. Remember from the last example that we know this is the 4th row, so we can find the 5th row directly from that, 1, 5, 10, 10, 5, 1, and so now we can just plug in these coefficients. And simplify. So what we end up with is 2 to the 5th times x to the 5th, 32x to the 5th, minus 240 times x to the 4th, plus 720 x to the 3rd, minus 1080 x squared, plus 810 times x minus 243. Find the 10th term of a plus 4 to the power of 12. Remember that our binomial formula says that a plus 4 to the 12th is equal to sum from k equals 0 to 12 of 12 choose k a to the power of 12 minus k, b to the power of k. So our 10th term corresponds to k equals 9. So if we plug in k equals 9, what we get is 12 choose 9, a to the power of 12 minus 9, b to the 9th, which is equal to 220 a to the 3rd, b to the 9th.